Okay, folks. Okay, just make sure. Everyone has their packet? Okay, last time we talked about a new kind of function called exponential functions. So you just have to make sure if it's exponential, we know that the variable will be an exponent. You guys take a look at that later. Okay, go ahead and put that away for now. Okay. Just join us. Oh, okay. Don't know. Okay. Domain. Remember the domain of the exponentials? Infinity and beyond. Yes. The range. Let's see. What was the range of these guys? Y'all see that? It's all been 0 to infinity. Does it include 0? Does not include 0. They always cross through the point. Let's see what they always cross through. Which point? Is this true? They all cross through 0, 1? They do indeed. Oops, 0, 1. Because f of 0 equals 1. Therefore, the y-intercept is 1. The x-intercept is... What's the x-intercept? None. If b is greater than 1, now remember b just is the base of our exponent. Then the graph is an increasing function. And if it's between 0 and 1, then it is decreasing. We did a couple of, well, one example of each at least. Did we do 2 of each? We did 2 of each. We know that f of x equals b of x has an inverse because it is, what kind of function has an inverse? Remember? It's been a while for this. 1, 2, 1. Does that sound familiar? 1-to-1 function. But I'm gonna have you sit on over next to me always for today, please. Discuss with the neighbor. What's a 1-to-1 function? Okay, so I heard it. Each input has 1 output. Isn't that a function though? What makes it 1-to-1? It has 1 unique output. 1 unique output. So in order to, there are 2 tests that it has to pass to tell that it's a 1-to-1 function. It's passed the vertical line test and horizontal line test to be 1-to-1. The graph of f of x equals b to x approaches, but does not touch the x-axis. This is called a horizontal asymptote. Okay, it's catching us up to speed. Okay, the parent function is y equals what's the parent function for a? It is 2 to the x, thank you. Yeah, then you're right. B to the x is kind of the form, but the parent here is what y equals 2 to the x. And transformation is that this function is going to move 3 down. I don't know it's 3 down and not side to side. Not in the function. If it says something like 2 to the x minus 3, that would be in the function. I'll say versus this. This is in the function. So that's why it's 3 down. So let's go ahead and graph this. How many points do I care about? I care about 3 points and that horizontal asymptote. So I'm just going to do y to the 2x first. Put the points for y equals 2 to the x. Check with your neighbor once you've done that. Make sure they got the same ones you did. So the 3 points I care about are, let's see, I'll call on someone. Ethan, what do you think? 0, -2. I'm talking about the parent function first. It's not, it looks like you went to the transform one already. Okay. Thank you. You could. I'm not really looking for the 2, 4, but also looking for -1, comma, 1/2. So you're right, that point is also on the graph. And then we're just gonna take each one of these and, like you said, move them down. So I'll do this one in green. 1. I think that's what you said, right? And it would make the most sense if I also move the horizontal asymptote, which just comes down 3. And something like this. I just find that once I have the graphics, a little bit more comfortable for writing the domain and the range. Better and write the domain and range for this graph. I'll call on someone to help with those two. You have domain and range. Mateo, what'd you get? Yes, please. Thank you. Are we good? Any questions? That's what I was wondering. Why is it 0 to infinity? Or why is it -3? Okay. Yeah, range is floor to ceiling, so that floor has become -3. Does it hit that -3? It does not. So we can't include it. Thank you, Mateo. And thank you. B, what's the parent function? Y equals 3 to the x. And the transformation? It is a stretch. Is it vertical or horizontal? Vertical, because that 3 is outside. Vertical stretch by a factor of 3. So do the same thing. Our parent function is 3 to x. How many points do I want from the parent function? 3, maybe 4, just to make it nice. But at least a 3 for full credit. Become one lucky user in just a moment. Make sure you check in with your neighbor. Are you ready? And for the graph, the domain, and the range. Then you and your partner, make sure you're both doing okay. Are you ready? Ready or not? Let's see what you got. Diane, help us out. What'd you do for the parent function? 1/2. 1/3, right? 3 to negative first is 1/3. So -1/3. I feel like you let someone talk you into that 1/2. 1/3 is correct. And what else? Are we sure it goes to 0, 1? We're good with that? All of them do. Before all the parent functions do. Keep on going. 1, 3. Do you want to do one more just for good luck? Like 2, 3, 9. Thank you. Nice. I sprung that on you, handled it like a champ. So this is our parent function. Let's take the original 3 points. What should we do with them? Dan, what do you think? What do we do with those 3? What happens? Yeah, so that first one on the left, that was at one height of 1/3 becomes 1. Are we good with that? 1/3 times 3 is 1. And then what happens to that one that was at 0, 1? What's that? Goes to 3, 0 to 3. And then the next one, 1/3 becomes 1/9. There you go. Should we do the other one? 227? No, not gonna fit. So this is what we're looking for. Looking at this, and then we know that it's gonna adhere to that horizontal asymptote. Okay, you're not done yet. Can you tell us what the domain is, Diane? Okay, and the range? Do you agree it's still 0? Thank you. Any questions? Okay, nicely done. Maybe a couple more. C, can you show me what transformation is happening there? Show me just in gestures. This is a negative that is outside. That's why it is reflected over the x-axis. I'll give you a moment to do that one. Then what are you doing? You're what? Oh, really? As you continue your progress, seconds from time to time. You're doing C and B, so if you don't see, keep on going. We're going to finish both. Okay, folks. Let's do this. I give you 20 seconds. Okay. Tyler, I finally made a popsicle stick for you. Can you help me with C, please? What's the parent function? Just a parent function for a C. The parent function is y equals. I feel like you really want to do D. Is that what you're saying? Okay, 2 to the x. Cool. And the transformation for x-axis. Cool. Nice. Okay, and for the graph, tell me what you did. Okay, let me plot like you said. Okay. Cool. And that's kind of enough, isn't it? What happens to the horizontal asymptote? It stays. Anything that is on the x-axis will stay on the x-axis in that reflection. Good. Did you do any other points or just those three? Two, -4, I think you mean?
Oh, yeah.
And you can do 3, -8 if you wanted to. Okay. Are we good with that for the range? Thank you for starting at the bottom, -infinity up to 0. Good, down to infinity 0. Any questions? Okay. Let's do D together. D, we know the parent function is y equals 1/3 to the x. Yes? How many points do I care about? 3. Let's do the easy ones. 1/3 to the 0 is 1. 1/3. What else is he? 1/3 to the. Maybe easy for you. Let's do an easier one, the -1. 1/3 to the 1, of course, is 1/3. We could already see that this is what kind of a function? It's decreasing, isn't it? So going to the left, it's decreasing. To the right, it's increasing. So when I plug in a -1, what should I get? I'm gonna get a positive value, 1/3. The -1, it's gonna be above 1. Is it 3? Yeah, we take the reciprocal, so it's 3 to the first power. It just becomes 3 right there. That's the parent function. Of course, we're gonna move this 1 to the right, 1 to the right, and 4 to the down. So just take those 3 points and just move them 1 to the right, 4 down. Got my green pen. 1 to the right, and 1, 2, 3. Does that seem about right? 1, 2, 3, 4. Oh, no, I did not do that right. 1, 2, 3, 4, there we go. Like that. And of course, I'm also going to move the horizontal asymptote. Should I get some more points? No, this is enough. This will give you full credit. Etc. Then etc. This direction. Any questions? Perhaps your question is, we have a couple minutes just to absorb this or zone out. In which case the answer is yes. The time is now 1:02. We'll resume at 1:06. You started on it. Like, what do you think about next year's cell phone policy? Do you know anything about it? Just keep in your backpack. What happens if you don't? Take it away. You die. You die. There's someone with condoms.
Yeah, so bad. I even checked the IHW.
What's that?
Yeah, that.
Birds of mentioning. Yeah. the birds of mentioning. I don't know how it works. I think here, the first offense, they take it away, and then you come get it the end of the day. And after that,
Yeah, no, that's all.
is that's how it's not. Or you get touched too.
Last week, was the day,
Huh?
There's like the beginning of the year, and check it out. Maybe,
Yeah.
Like, so it sounds like
Oh.
you're talking about pocket.
Just if it's in your back pocket, wow. You can, we should never see that.
Oh, okay.
I think if it's out of your pocket at all, then it's, and someone sees. That's it.
I'm talking that's like, I don't know.
What's it?
Like phones. You know, like, all these guys. Yeah, I think.
I'm not sure, we'll see. It's gonna be tough. Definitely.
Yeah, but I think not having the IHW.
You think what?
Not having the IHW.
Oh, that'll be interesting, yeah, for classes and such.
Yeah.
That's big, isn't it? Yeah, how are we gonna know which class to go to next?
Yeah, that I actually don't know. Like, I have no idea. Like, it's nice.
It's just like, I'm going to.
Oh, yeah, like, I think that's like an email, like, but then you get like seminar, I gotta change it. You know, almost a computer all the time. You know, like, that, these things, like,
You memorize it, you know? I think that people don't memorize it at all.
yeah, I don't, oh, yeah.
I bet
I, you know, I have to.
you probably have, hey, do you all know what you have like? Work?
Well, you know, I don't even know if I like walk. I don't know. I don't even, like, I don't even know what I have to walk. I don't even know when I'm. I just look at the day before, so I think that, oh, I don't know.
Maybe you did, or just like 135 and then. People, you know, I don't, you can get that. I think.
How long do you?
Oh, no, it's not, right.
It's about the time to be working on your time.